Hello and a very warm welcome to the Discover Reading podcast. Today we have got a fascinating and timely episode about climate change with Professor Richard Allan from our Meteorology department. We were incredibly lucky to be able to speak to a world-leading expert about one of the greatest challenges facing humanity. Richard gives us clear and concise information about the dangers of climate change now and in the future. And he explains his contribution to the Intergovernmental Panel on Climate Change report that will form the scientific basis of government policy making at the COP26 in Glasgow next month. Enjoy. Well, just to kick things off then, Richard, if you could just tell us who you are, first of all, and what you do.
Yeah, so I'm Richard Allan. I'm a Professor of Climate Science in the Department of Meteorology at the University of Reading. So I teach and conduct research into climate variability and climate change.
Fantastic. And just to build upon that, Phil and I did notice, Richard, that you recently contributed to the Intergovernmental Plan on Climate Change, which was released back in August. Could you tell us what this is exactly and why is it important?
Sure, yeah. So the IPCC is the Intergovernmental Panel on Climate Change, and it's been running since the end of the 80s. They provide periodic assessments of the state-of-the-art climate science, and this is in looking at the physics, but also looking at adaptation to climate change and mitigation, which is what we do about it. So I was involved in the summer, and I've been involved for the last 3.5 years in working pretty hard in my own time, alongside my other work at the university, in assessing the state-of-the-art knowledge on climate science. And this is the physical science basis for why is climate changing and how will it change in the future. So this involved working with a bunch of other scientists from around the world. The whole report involved hundreds of scientists all working on different chapters. I was working on a chapter on the changing water cycle. There were other chapters, for example, on extremes, which I contributed a bit to, and on observations. There's about 12 or 13 or 14 chapters in this. And so we worked on this for a long time. We had lots of rounds of reviews, to independent reviews, to make sure the assessment is watertight. And then this culminated in the summer, in a really busy period for me, at least, because I was involved in contributing to the summary for policymakers. So this involves summarising everything in the report to some really key statements that will help to inform policymakers, particularly at the upcoming COP26 meeting in Glasgow. And the really important thing that I'll finally add about the IPCC process is the fact that the governments are involved in the process at this later stage. So in the summer, I was involved with the approval process, whereby 195 different countries' delegates had to approve word for word each line, each word, each paragraph of our summary for policymakers. So because they're involved in this process, it makes it have much more gravitas in terms of influencing the policy decisions that need to be made at the COP and ongoing policy meetings.
That's fantastic. And as you said, like the governments had to agree on kind of each part of this report. Is this report something like the Bible of what people will refer to? Is this the main authority that governments would refer to when they're thinking about climate change and what to do about it?
It is the main authority on the state of the science, so not like the Bible in that sense, but it is certainly the authoritative state-of-the-art knowledge of climate science. And as I mentioned, because it's also been approved by 195 government delegates, it means that it carries a lot more weight in these policy meetings.
What were the key recommendations that have come out of that report?
Well, this report doesn't necessarily come out with recommendations. It lays down the clear messages of the state of climate science. And some of the key messages are, although we know climate changes very naturally, we know that over the last 5 decades or so, humans have been the prime drivers of climate change. In fact, the only real drivers of the change that we've seen in this period. It's shown that we can attribute observed changes in climate to human activities, particularly the release of carbon dioxide as part of burning fossil fuels, but also in cement making. And it's shown as well that how the carbon is building up in the atmosphere, how it's building up in the land, how it's building up in the ocean. And this report also shows what the projections are in the future. So it looks at how things are going to change in different scenarios. So if we have a scenario where we carry on emitting large quantities of carbon dioxide into the atmosphere, and another scenario where we strongly mitigate, reduce and cut rapidly the carbon dioxide emissions, and various scenarios in between, it looks at how the climate will play out, how the change will affect different regions. Which is one particular strength of this new report, is that it's looking much more closely at the different regions. And where it does inform policy decisions is the fact that the science is absolutely clear that if we don't follow the scenarios with the rapid, sustained cuts in carbon dioxide, then we cannot limit climate change to safe levels. So those are the clear messages it lays out. There are other reports next year which will look at the adaptation that we can do to adapt to climate change, and also some of the more specific technical policy options that will be open. But generally, this report is laying down the science, and the science is pretty clear what policymakers need to do, which is to cut greenhouse gases rapidly over the next few decades.
Fantastic, absolutely. Because you mentioned COP26, I thought maybe this is a good opportunity as well, just to explain to our audience what exactly that is, what we should expect from it. And I'll be quite interested to get your perspective in terms of, are you actually hopeful ahead of COP26? Because obviously, if you look back to some of the Paris climate accords, things were agreed, a certain president came in the United States and torpedoed elements of it. But are you actually much more hopeful ahead of this particular climate summit?
Yes, I am hopeful, and in the same time, I'm also pragmatic, because these meetings are very difficult. They're very complicated because they involve all the different nations, all with their own particular issues, all with their own agendas. So it makes it very difficult to negotiate what each country is going to contribute to this process. Now, this is not my exact area of expertise. My area of expertise is the fundamental science that underpins this. But of course, I have an overview of what goes on, and I've been involved in the approval process, which was very complicated itself because it involved lots of different governments, all with their own agendas. What I am hopeful is that there'll be a ramp up in the ambition, in the scale and the timeliness of cuts in greenhouse gases, particularly carbon dioxide. So that's what I'm hopeful of. What I'm perhaps more pragmatic of is that it won't be perfect. We know that it's not going to be as good as we would like it to be, but we want it to be as best as it can be at this stage, and then we will continue the process, because that's what these series of meetings have been producing. As you mentioned, the Paris Agreement was a landmark agreement. That meeting wasn't perfect in every sense, but it produced a real foundation. There were other Convention of the Parties meetings, for example, in Copenhagen, that didn't go as well as people expected. And you're going to get bumps in the road, and there'll be bumps in the road in COP26 in Glasgow. But I think the momentum is there. We're going in the right direction, and we just need to ramp up the ambition of the cuts in greenhouse gases that are going to be required to limit climate change to acceptable levels.
I think in terms of kind of the media's coverage of climate change, something I've definitely noticed over the last decade is that a lot more stories about extreme weather conditions caused by climate change. And I think for myself and other people, sometimes that can be a bit confusing. So, by extreme weather, I'm talking about flooding, drought, hurricanes, forest fires, extreme cold, and all of these things are related to, what's often called just global warming. So as a layperson, it can be a bit confusing as to, how all those things relate to warming. So could you explain how, global warming causes all these different types of weather conditions that are so hazardous to human life?
Yeah, it's a good question. So climate change or global warming doesn't necessarily cause the extremes. Weather patterns cause extremes. So when you get the ingredients of the weather coming together to give you a very long, dry, hot spell, that will have impacts in terms of heat stress, drought. When the weather conditions come together to give you heavy rainfall, this can sometimes lead, like we've seen in this year in 2021, we've seen extreme flooding in various regions in Germany, in China, and we've seen wildfires, of course, in Europe, in California, and wildfire depends on there being hot conditions, dry conditions, lots of dry matter that can burn rapidly. So weather conditions generate the where and when these extremes occur. But what climate change is doing and what warming of the planet is doing is intensifying these extremes. Now, the reason for this is quite clear from a physics point of view, because a warmer atmosphere is essentially a more thirsty atmosphere. It's more capable of sucking moisture out the ground. So when you get hot, dry spells, the severity of the heat and the severity of the dryness and the drought, the aridity, will be magnified. And at the same time, this water that's being taken from one region is being moved by the winds into other regions. It's been ingested into weather systems and expunged as heavy rainfall. So a warmer atmosphere has more moisture in it. And when this is taken into weather systems, that means that when you get heavy rainfall, that heavy rainfall is even more intense, and the associated flooding is even more intense as well. So essentially, weather causes the extremes, but warming of the planet due to human activities is intensifying these extremes, making them worse.
That was perfectly explained. And I'm kind of quite curious to get your perspective as well, Richard, because sometimes cynics will often argue back and I would say something such as good luck getting all the major countries in the world to go and work together and contribute to a plan if you want to try and reverse many of these changes. Just how much of a change do we need to see in human activity, say, over the next 20 years to reverse and correct some of these changes? If, for example, a major player like China didn't come on board, could we still achieve a massive impact nonetheless, for example, by having the Western world and other Asian countries could contribute and hopefully, reverse some of their activity? Just how much of a change do we actually have to see?
Yeah, so we need all countries to be contributing, particularly the big emitters like China and the United States of America. And we need massive changes. So we've already seen in the COVID pandemic how there have been rapid substantial changes to society. These kind of things are possible to do if the need is there, and the need is there with climate change, because we're already seeing the intensification of extremes. We're seeing flooding and drought events that are much more severe because of human caused climate change. So we need these changes to be rapid. We need them to start now over the next 10 years, let alone the next 20 years. We need them to be across all sectors. So that's including domestic, so heating, transport, industry, agriculture. We need them across all sectors. And so we need absolutely substantial changes across all these sectors. And we need it to be collaborative. It's not just about governments. It's not just about individuals. It's about joining up all these areas, so going from local groups up to universities like the University of Reading, which is doing great stuff in terms of sustainability. We're looking at companies, Microsoft, Google, and we're looking at local authorities, and then up to the government level and at the city level. So all these scales need to be involved collaboratively, and there need to be massive changes to cut greenhouse gases from all these sectors. So the challenge is huge, but the science is there, and what we've produced in the University of Reading and many other institutes around the world is the clear science that says what we need to do. Now it's about governments and all the other areas of society to come together and take action to reduce greenhouse gases substantially and rapidly.
For sure, and I think those were quite an important message. Yes, the challenge is huge, but previous generations faced massive challenges. You look at the Second World War generation and the huge challenge to rebuild the entire world and the entire economy in the wake of that devastating conflict, and yet that generation did it. So different time, different scenario, but it showed that countries can come together and put in systems and work together. But Phil did give me permission to ask Richard a question, which I've always been curious to ask an expert about. But this is just quickly taking us away, a little bit away from man-made climate change into a bit more of a natural climate change, and just how wary and just how prepared are we for, say, an eventuality of a kind of natural climate change. So I'm a bit of a historian, so I've read about the eruption of Krakatoa and the impact that had upon the climate. There was eruption, there's quite a lot of emerging historiography on this, but the Samalas eruption, apparently that dramatically impacted the Mongol Empire. Do you think that we'd be quite well prepared for a natural climate changing event, or is that literally the kind of thing which you simply cannot prepare for?
Well, you can certainly be prepared for it. Some adaptation measures you can take for human-caused climate change will also help with natural climate change. So you mentioned volcanic eruptions. There's the possibility of supervolcanoes going off, spewing off huge quantities of particulate matter, blocking out the sun for a number of years and cooling the climate. The chances of this are very low, but it's happened, as you said, in the past, and it could happen in the future. The last major volcanic eruption we had was actually Mount Pinatubo in 1991 in the Philippines, and that caused just a mild cooling of the climate, but it also disrupted weather patterns. So it caused some noticeable effects, and that was certainly easy enough to adapt to, but it still caused some substantial impacts. Having a series of big explosive eruptions or a supervolcano would obviously lead to some more difficult situations to deal with. One thing I suppose I'd add is that aside from volcanoes, natural climate change tends to operate on slower timescales, so slower changes in the brightness of the sun, slower changes in how the Earth orbits around the sun. And we know that 20,000 years ago, we're in the midst of the last glacial maximum, so like an ice age. Ice sheets were moving across northern Britain. The planet was about 5 or 6 degrees Celsius colder. And we know why that is. That's because of these very slow changes in how the Earth orbits the sun. They're predictable. We understand that. These things change quite slowly. So these kind of things we can adapt to, whereas the rapidity of human-caused climate change is more challenging to adapt to in terms of the rate of warming, the rate of changes in extremes, the rate of sea level rise. Whereas your example of the volcanic eruption, of course, a big volcanic eruption could cause climate change very rapidly, and that would need very rapid adaptation measures to be in place, early warning of weather pattern changes and that kind of thing. So yeah, it's certainly a valid point, but the final thing I'd say is that if societies are already crippled by the effects of human-caused climate change, they will be less able to respond to and adapt to a natural event like you've mentioned as well.
Excellent, thank you. That's something I've always kind of quite wondered, so very nice to have it answered. But because you were mentioning data, probably quite a nice opportunity to go on to our fourth major question. So in your research, you use Earth observation data to explore things such as fluctuations in clouds and rainfalls, to assess the realism of climate prediction models. But my understanding is that even normal weather forecasting is not something that can be done 100% accurately, more than in a few days in advance. Why is that exactly? And what are the implications of that for creating accurate climate change prediction models?
Yeah, it's a good question, and weather forecasting has actually improved massively over the last 10, 20 years. And one of the reasons for that, you mentioned Earth observation data, is the fact that these forecasts really depend on having very accurate starting points for the simulations. If you have sizable errors at the beginning, these errors will grow and eventually they'll cause your weather patterns to move out of sync and give you very inaccurate predictions. There's also been a massive improvement in the models themselves, in the physics involved, in the fine resolution they're able to capture. But the fundamental difference about a weather forecast model and a climate change model is the fact that in weather forecasting, you're trying to predict the where and when of weather events. So you want to know, is it going to rain in Reading on Thursday at 4 o'clock in the afternoon? Whereas in climate change, you're not trying to predict whether it's going to rain in Reading on, the 4th of October, 2084. That's not the task that you're trying to do. What you're trying to do is look at the changes in the characteristics of the weather. How warm on average is it going to be? How frequently will you have rainfall above a certain threshold that could give you flooding? And that's a very different calculation, because it doesn't so much depend on the initial start point from your simulations. It depends on how the simulation evolves over time, which depends on these kind of amplifying factors, like do clouds amplify warming, do circulations shift slowly as you warm one part like the Arctic more than other latitudes. So it depends on much slower parts of the climate system, and you have predictive ability in looking at the characteristics of weather, how they change, rather than the pinpointing whether a storm will go off in Reading in the future at a particular time. Now, these climate change prediction models are actually built on the weather forecast models, so they simulate the weather patterns, but a particular they include a lot more physics as well. So as well as the atmosphere, it's really important to include the ocean circulation. So you're simulating how the ocean circulates, how it moves salt and heat about the system. You're also simulating giant ice sheets like on Greenland, on Antarctica and glaciers, and how they change very slowly over time. So you're adding in more physics into these models, and you're trying to solve a different problem to the weather forecasting. So rather than the where and the when, it's the how is the fingerprint of your weather that's expected in a region going to change over time.
That's fascinating. And as you were saying, that obviously your ways of measuring things have got much better recently. I was wondering, in terms of kind of climate change models 10 years ago, are those proving to be quite accurate now, or in those 10 years have things completely changed sort of technologically, and now they're not as accurate as they might be in 10 years from now? There's
certainly been an improvement in the realism of climate model simulations, because simply the increase in computer power that's enabled us to add in more physics, so more processes, so more intricate processes to do with clouds, to do with the land surface and vegetation, those kind of things, to do with particle pollution in the atmosphere. But it's also allowed us to run the models at a finer scale. So rather than being at 200-kilometre grid squares, they're going down to 100, down to even 10, and even they've been starting to run them at kilometre scale, where they can actually simulate individual thunderstorms and things like that. So there's that aspect. The other thing that's really powerful is the fact that we'll be able to run these simulations hundreds of times. The reason for doing that is because of the weather, there's chaos going on. So if you run the simulation many times with slightly different initial conditions, it will give you slightly different evolution. The weather patterns will evolve in their different ways. And in doing that, it gives you an idea of the spread of what the likely changes are in the near term in terms of the climate. So there's three aspects there. The models, the simulations have got much better. And I think you mentioned as well, the Earth observation data is improving, and that's helping as well to look in more detail at some of the intricate processes like clouds, like vegetation, like the land surface and moisture in the soil. And in doing so, you can understand the physics of what's going on better and code this up in the models much more realistically. So that's helping as well to both improve the physics in the models and then to actually use these observations to evaluate how realistic the models are and then to make these models better. So over time, all these factors are making the simulations more realistic. They'll never be perfect, but they'll always be useful, and they're getting more and more crucial, in fact, in determining policy decisions and preparedness for extreme events.
Is it simplifying things too much to say that once you've run all these different models, you almost come away with a kind of worst case scenario, best case scenario, something in the middle, or is that simplifying things too much?
No, that's actually quite insightful, because like I've mentioned, you can run these models with different scenarios. Say a scenario where we're carrying on massively relying on fossil fuels, or one where we've cut fossil fuels. So there's that aspect of it. But there's also the fact that even if you run one model with a particular scenario, if you run another model, one model in Reading, for example, one model in New York, they're different models, they're using the same physics, but interpreted in slightly different ways, they can give you different answers. And so when you run these models out, they almost show unfolding different storylines that are all plausible. And storylines is a new area of research that's been really pioneered in the Department of Meteorology at the University of Reading, amongst other places. And that's to say, there are these particular storylines that could happen. Some are more likely than others, but still there are all these plausible storylines. And we need to think about, if this storyline unfolded, how do we adapt to it? How do we second guess what's going to go on? So we use this information to make policy decisions. This is kind of a new way of looking at it. So it's not a simplistic question at all. It's actually a very valuable thing that we can use to interpret these complex computer simulations.
Okay, no, that's good to know that that wasn't too simplistic a way of looking at it. I think that also made me think of the IPCC report. I read that sort of one possibility is for the UK specifically is a collapse of the Gulf Stream. I think that, although that seemed like it wasn't that likely, and I wondered whether, still mentioning that but saying it's not that likely, is that the same sort of thing, that's come up as one possibility for the UK?
Yeah, so this IPCC report, another factor that's distinct from previous ones, is the fact that we're looking at low likelihood but very high impactful situations. So one of these is the one that you mentioned, which is what's called the Atlantic Meridional Overturning Circulation. So the Gulf Stream is the upper part of this. So it's an upper level flow of warm, salty water that then it cools, it freshens, and it becomes very dense and sinks in the North Atlantic, and that draws more warm water up to replace it. And the return flow in the depths of the ocean go back south again. And this circulation of the North Atlantic is absolutely fundamental for European climate, because, of course, if you look at on a globe, you follow the line of latitude from, say, London across to Canada, you know that in the winter, London is much, much, much milder than Canada, which is frozen like minus 20 degrees C in the middle of Canada in winter, whereas here it's usually above freezing. So part of the reason for that is that we have this warm flow of water. We also have these warm, mild winds from the southwest, and that keeps Europe warmer than it otherwise would be. So if this whole circulation was to shut down, that would obviously cause chaos for European weather patterns. Now, it's happened in the past. We know this from indirect paleoclimate observations, which have shown that as the climate was warming up after the last glacial period, a massive discharge of fresh water interrupted this sinking, because fresh water is not very dense, it's light, and it stopped this flow of warm water, and that interrupted this warming and sent Europe back into cold conditions. Now, that wouldn't happen in the future. Well, it would be slightly different. So in the future, we know that there's going to be extra melting of ice, there'll be extra rainfall, and extra heating the upper layers of the ocean, and that could slow this overturning circulation, because the upper levels become less dense, they're less likely to sink and draw in this warm flow of water. And we've already observed that this flow has decreased very slightly. Now, what you mentioned in this IPCC report, there has been an assessment of what are the likelihood of this whole circulation shutting down. And there's medium confidence that it will not shut down. It's pretty likely that it will carry on slowing, but it's medium confidence that it won't shut down. But it's not for definite. It's still the possibility of this low likelihood circumstance of this whole circulation shutting down. Now, rather than sending the Europe into cold conditions, it would instead just keep things cooler than they otherwise would be. So it'd actually temper the warming. But the crucial thing that it would do was it would totally disrupt weather patterns across the world, and it could lead to massive drying in the Mediterranean, big shifts in the monsoon belts. So these studies have shown that it will be a really chaotic thing for climate across the world, and those climate changes across the world would then impact the UK through food shortages and other aspects. So these things are assessed. They're not very likely, but they're still possible. So that's why they're assessed as part of this report.
So I guess related to that, we wanted to ask a broader look at your predictions for this century, really. Obviously, your research is on, or part of it at least, on sort of how much the Earth will warm up this century and the implications of that for the global water cycle, and then obviously then the implications of that for societies and ecosystems that depend on that. So again, that kind of knock-on effect. So yeah, we were wondering what your predictions were for the century and what we can do to improve things, really.
Yeah, so in terms of the predictions for the future, there's a range of possibilities because we know that there are amplifying factors in the climate system, particularly some types of clouds can amplify climate change. Other types of cloud can change such that they dampen the climate change effects. So there's a range of possibilities, and this IPCC report has actually assessed a narrower range, so we're more certain of how things will change. And it looks like, if we carry on in the current trajectory, then we're looking at a warming of the planet of maybe 3 or 4 degrees Celsius by the end of the century, which doesn't seem massive, but when you consider that the height of the last glacial maximum, when ice sheets were encroaching into northern Britain, the planet was only around 5 degrees C cooler. So we can see that a 4 degrees C warmer world would be absolutely catastrophic in terms of the effects. It's a completely different planet. So the intensity of the extremes, the compound effects of different factors going on, you'd have higher sea levels, compounding with the fact that when you get heavy rain, that can cause flooding, compounded with coastal flooding. So there'll be huge effects, there'll be huge changes. If we do something about it, which we are doing, but if we ramp up our ambition over what we're doing and rapidly cut carbon dioxide and other greenhouse gases like methane and nitrous oxide, then we can avert the worst of these changes. We can hopefully limit climate change to below 2 degrees C above pre-industrial times, maybe even limit it to 1.5 degrees C above pre-industrial. At the moment, we're already about 1 degree C above pre-industrial, so we're getting very close to that lower limit already. So those are the kind of predictions, and there will be an increase in the intensity of rainfall when we get very wet conditions and associated flooding. There'll be hotter heat waves. Some of the moderate extreme events will be promoted up to the Premier League of extreme events, whereas the Premier League extreme events will be promoted to something that's never before been seen in a 3 degrees warmer world. So we're going into completely uncharted territory. Whereas if we're going to limit the climate to a warming of just 1.5 degrees C above pre-industrial, we'll still see these increases in extremes, but to a tolerable level, to an adaptable level. One final point to make about the predictions is that there are some aspects of climate change that are irreversible. And for example, sea level rise is one of those. There's been a lot of work done at this at the University of Reading, looking at how ice sheets melt, how deep ocean heats up and expands, and you get sea level rise because of the ocean expanding as it gets warmer and because of the melt from land ice. Now, the trouble is, it takes hundreds and hundreds of years for the deep oceans to finally come to their new warmer temperatures once you've come to a new warmer climate. And it takes hundreds and hundreds of years for these huge ice sheets like Greenland to melt and come to their new, smaller equilibrium. And so, although we can expect a sea level rise of maybe up to 1 metre this century, if we carry on at our current trajectory, further out into the future by 2300, even if we limit climate change to 1.5 degrees, we can still expect sea level to rise by maybe 2 metres. And if we carry on our current high emissions trajectory, we can even see sea level a rise of 8 metres or even higher. So just imagine, what that would do to southern Florida. Now we're talking over hundreds of years, so clearly that's well beyond current human lifetimes, but there will hopefully still be societies around then. So we will need to adapt in the very long term to this continual sea level rise. So that's the final, more doom and gloom type scenario. But on the lighter, more hopeful side, we can do something about many of the climate changes, the increases in extremes. We can limit their severity by cutting greenhouse gases, and we can also do things by cutting methane. Will also, as well as limiting climate change, will actually improve air quality. So these things that we can do that can really improve society in multiple ways. So those are the predictions. They look pretty dire if we don't ramp up our ambition in terms of cutting greenhouse gases, and that's why the IPCC work and the work going on at Reading is so important in forming the policy decisions that are being made at these meetings like COP26 in Glasgow and future policy meetings.
Okay, it's so good to hear that there is hope, and changing our behaviours and government policies can improve things for us in the future. But it is really sobering to hear how much work there is to be done, and also the impact of just doing nothing, really. And it's been absolutely fascinating talking to you, Richard, as someone at the absolute forefront of such an incredibly important issue. So thanks so much for coming on the podcast.
No problem. Really, really great to chat with you guys.
Thank you.
Thank you very much. Well, wow. What an incredible and insightful talk that was, as today's generation face the clear and present danger of climate change, not to mention the small matter of COP26 as well. And things are only getting more exciting still, as over the next few weeks, we will welcome Dr. Fola Adeyemo for a study of domestic and international law. Dr. Christoph Ardent will tell us all about the recent German elections and what comes next, while our brilliant PhD student Vicky Bolt is on to discuss conservation and majestic elephants. Stay tuned, but until then, goodbye.